Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 2 in a session May-June 2021 Paper 2-1. So let's start with the first question. Question number 1, solve the inequality. So when I open this inequality, the absolute function, we have a plus minus 3x minus 7 is less than plus minus into 4x plus 5. Let's do scaling on both sides. In order to get rid of this plus minus, we have to do scaling on both sides. So we have 3x minus 7 whole square is less than 4x plus 5 whole square. Let me open the square. We have 9x square plus 7 square is 49 minus 2ab. So we have minus 2 times 3 times 7 minus 42x. This is less than 4 square is 16 x square plus 25, and we have 2 times 4 times 5 40x plus 40x. Okay, shifting all the terms to the left side, 9x square minus 16x square minus 42x minus 40x plus 49 minus 25 is less than 0. Okay, 9 minus 16 is minus 7x square, and minus 42 minus 40 minus 82x, and 49 minus 25 is 24 plus 24 is less than 0, right? Okay, now let me take negative sign common. So we have to reverse the inequality. 7x square plus 82x minus 24, this is greater than 0, right? Now let me factorize this. Okay, 7 times negative 24 is minus 168. Okay, 2 times 84 is 168, and 84 minus 2 is 82, right? 7x square plus 84x minus 2x minus 24 is greater than 0. All right, let me take 7 common and x common. We are left with x, and 84 divided 7 is 12 plus 12x 12. Taking minus 2 common, we have x plus 12. This is greater than 0, right? So the factors are x plus 12 and 7x minus 2. This is greater than 0. So from here x is equals to negative 12 and x is equals to 2 by 7, right? These are the two solutions. Now we have to check when this is greater than 0. So if I can draw the curve for this, the parabola, okay, and we know that we have two roots, minus 12 and 2 by 7 is 0.28. okay, 0.3 we can say. Okay, so this is the quadratic equation where x square coefficient is positive, so it means the parabola opens upward. This is the opening of the parabola, right? One root is minus 12, the other root is 2 by 7, right? So we have to find when it is greater than 0. It's more. So the solution is it is more when x is all the values of x that are less than minus 12 and all the values of x that are greater than 2 by 7, more than 2 by 7 and less than negative 12. Question number 2, by first expanding sine theta plus 30, solve the equation sine into theta plus 30 cosecant theta equals to 2 for theta is between 0 to 180 degree. All right, so here we have to use the sum formula, sine a plus b, which is sine of theta cos 30 plus cos theta, this is theta, sine 30. Right, first we need to expand this and then we have to solve this equation. Okay, so what is cos 30 in degrees? Cos 30 is square root of 3 by 2. So square root of 3 by 2, we have sine 30, sine theta, and sine 30 is 1 by 2 plus 1 by 2 into cos theta. Right, now we have to solve this equation. Sine into theta plus 30 degree cosecant theta 1 over sine theta, this should be equals to 2. The value should lies between 0 to 360 degree. Okay, so this is expansion. We can say square root of 3 over 2 sine theta plus 1 by 2 cos theta, its product with 1 by sine theta, and this should be equals to 2. Right, okay, so let me divide all the terms by sine theta. We have square root of 3 divided by 2. Sine theta by sine theta is 1 over 2. Cos over sine is cot theta, this should be equals to 2. Right, taking 2 common, we have square root of 3 plus cot theta, this should be 2 is multiplying on the other side, this should be 4. Okay, so we have cot theta is 4 minus square root of 3. Okay, so if I can do the reciprocal to make it tangent, so tan theta is 1 over 4 minus square root of 3. Right, now let me solve for theta. So theta should be tangent inverse of 1 over 4 minus square root of 3. Alright, so tangent inverse 1 divide 4 minus square root of 3 is 23.79, 23.8. Theta is 23.8 degrees and tangent is positive in first and third quadrant. So for third quadrant we do 180 plus theta, 180 plus answer, which is 203.8 degrees, and theta is 203.8 degrees. So these are the two solutions that belongs to the given range of theta between 0 to 360 degrees. Question number 3 part A show that secant x plus cos x whole square can be expressed as secant square x plus a plus b cos 2x, where a and b are constants to be determined. Let me open the square. Secant square x plus cos square x plus 2 secant x cos x. Right, so secant square x, you have to keep this as it is, right, plus cos square x, this is 2, secant is 1 over cos x into cos x. So this is cancelled, cos x is cancelled with cos x, we are just left with 2. Right, so this is secant square x plus cos square x plus 2. Right, now we have secant square x and plus a, which is 2. We have to find b cos 2x, so we have to convert this cos square x into b cos 2x. Okay, so if I can say this is secant square x plus 2, so we can make cos 2x. We have an identity for cos 2x is 2 cos square x minus 1. In terms of cos square, we have only cos square x. So what we have to do with this cos square x, we have to multiplying and dividing by 2. We have cos square x and we have to minus 1 and plus 1. Right, okay, so we have secant square x plus 2 plus 1 by 2 is outside, we have 2 cos square x, right, and we have to basically dividing by 2 as well. 1 by 2 we can take, yes, for taking negative 1 common. We have negative 1, right? So 2 cos square x minus 1, 1 by 2 is outside, plus 1 by 2 is outside. So 2 cos square x minus 1 is cos 2x, which is secant square x plus 2 plus 1 by 2 cos 2x plus 1 by 2, right? So we have secant square x 2 plus 1 by 2, which is 2 plus 1 by 2 is 5 by 2. So a value is 5 by 2 plus the b value is 1 by 2 cos 2x, right? Now for part b, hence find the exact value of the integral from 0 to pi by 4 secant x cos x whole square dx. So we have to do integration from 0 to pi by 4 secant square x plus 5 by 2 plus cos 2x over 2 in the respect to dx. Okay, the integration of secant square is tan x plus 5 by 2 integration is 5 by 2x. 1 by 2 is outside. The integration of cos is sine 2x over 2. Substituting the limits from 0 to pi by 4. Right. So this is tan x plus 5x over 2 plus sine 2x over 4 from 0 to pi by 4. Let me substitute the limits, the upper and the lower limits. So we can say tan pi by 4 plus 5 by 2 times pi by 4 plus 1 by 4 sine 2 pi by 4. This is the upper limit minus the lower limit is tangent of 0 plus 5 by 2 into 0 plus 1 by 4 sine 2 into 0. This is 0. Sine 0 is also 0 and tan 0 is also 0. So the lower limit is 0, right? Tan pi by 4 is 1. Tangent of 45 is pi by 4. This, no, we are doing in radians. Wait. Yes. Tangent pi by 4 is 1 plus 5 pi over 2 times 4 is 8 plus 2 times 1 is 2, 2 times 2 is 4, pi by 2, sine pi by 2 is 1, so 1 by 4. So 1 plus 1 by 4 is 5 by 4 and 5 pi by 8 is the exact value of this integral. Question number 4. A curve has parametric equation x in terms of t and y in terms of t. Part A. Find the value of t at a point P on the curve for which x is equals to ln 4. So the point P lies on the curve, should satisfy the curve, right? So we can equate the x. We can say ln of 2t plus 6 minus ln of t. This is ln 4. Right? Okay, now we can apply the log property. Ln of 2t plus 6 divides t. This is ln 4. Taking anti-log on both sides or cancelling ln on both sides, we can say 2t plus 6 divides t. This would be 4. And 2t plus 6 equals to 4t. We have to solve for t. So we have 6 equals to 4t minus 2t. 6 is equals to 2t and 6 by 2, which is equals to t, and 2 times 3 is 6. So from here t value is 3. Right. Now for part B, find the exact gradient of the curve at P. Okay. So for gradient of the curve, we have x, which is ln of 2t plus 6 minus ln t. Let me find dx over dt, which is 1 over 2t plus 6 times 2 minus 1 over t. This is equals to 1 over t plus 3 minus 1 over t. This is dx over dt, right? Let me find dy over dt as well. So we have a function y which is t ln t. So dy over dt is a product rule. The first term is as it is, derivative of second term is 1 over t, plus the second term is as it is, derivative of first term is just 1. T is cancelled with t, so dy over dt, this is 1 plus natural log of t, right? Okay, now applying the chain rule, we will get the derivative. So we can say dy over dx at p, we have dy over dt times dt over dx, right? Okay, dy over dt is this, which is 1 plus natural log of t times dt over dx. We have to do the reciprocal of this. So if I can simplify this first, let me simplify this. If I can say dx over dt is t minus t plus 3 over t into t plus 3. This is t minus 3 over t into t plus 3. It's cancelled, so we have minus 3 over t into t plus 3. Right, let me substitute this over here. This is the reciprocal, so t into t plus 3 divided by negative 3, right? Now we have to find the exact gradient of the curve at the point P. So at point P, the t value is 3, because we solve this value t. At t equals to 3, we have dy over dx is 1 plus ln 3 times 1 over negative 3 into 3 plus 3. 3 is cancelled with 3, so we are left with negative of 6 1 plus ln 3, right? Question number 5. The diagram shows the curve with equation y equals to this. This curve has an equation. The curve has a minimum point at m. M is the minimum point. Part A, find an expression for dy over dx and show that the x-coordinate of m satisfies the equation. X should be this, right? So for the minimum point, we have to put the first derivative equals to 0. First, we need to find dy over dx. Let me apply the quotient rule over here. The denominator function is ln x. Derivative of numerator function is 3 minus the numerator function, and the derivative of denominator function is 1 over x, right? Divides denominator function square, ln of x whole square, right? Okay, so for minimum, point, we have to put this equals to 0. We can say y prime is equals to 0, so this whole thing should be equals to 0. So we can say 3 natural log of x minus 3x plus 2 over x. This should be equals to 0. So this term multiplying with 0 is just 0, cross multiplication, right? We have to find the coordinate of x. We can show that the x coordinate of m satisfies the equation, right? So here we can say 3x plus 2 over x. This is 3 ln x. Okay, so taking reciprocal on both sides, x over 3x plus 2, this is 1 over 3 ln x, right? And x is equals to 3x plus 2 over 3 ln x, right? You can see x is 3x plus 2 over 3 ln of x. So the x coordinate of m satisfies this equation. Now for part B, use the equation in part A, which is x is equals to 3x plus 2 over 3 ln x, to show by calculation that x coordinate of m lies between 3 and 4. So if x coordinate lies between 3 and 4, it means a sign change occur, right? So let me check at 3, and then at 4 we can check it later. So at 3 we have 3 here, and we can say 3 times of 3 plus 2 over 3 ln 3, right? 3 times 3 is 9, 9 plus 2 is 11 over 3 ln 3. Let me calculate this. We have 3 ln 3, 11 over answer, which is 3.3. okay, this is 3.3. so 3 is less than 3.3, right? Okay, so at 4 we can check at 4. We have 4 here. 3 times 4 is 12. 12 plus 2 is 14 over 3 ln 4. Okay, 3 ln of 4, 14 divide answer. This is 3.4. So 4 is greater than 3.4, right? 3 is less than 3.3 and 4 is greater than 3.4. So sign change occur. This implies x coordinate of m lies between 3 and 4. Right. Now for part C, use an iterative formula based on the equation in part A. Okay, make an iterative formula, which is xn plus 1. This is equals to 3xn plus 2 over 3 ln of xn. To find the x coordinate of m, correct to 5 significant figures. Give the result of each iteration to 7 significant figures, right? So as we know that the root lies between 3 and 4, so we can say the initial guess x naught, it can be 3.5. Let me take 3.5, right? Now make a column for xn and xn plus 1, right? So each iteration should be 7 significant figures. This is xn and this should be xn plus 1. So first x0, which is 3.5. So for 3.5, we can say that 3 times let me use the bracket, 3 times 3.5 plus 2 divides 3 ln 3 ln 3.5. Up to 7 significant figures, we have 3.3, 1, 2, 3, 4, 5, 6, 7, 2, 5, 9, 8, 2, right? Okay, now if we have here, we can put answer. This is 3.3, 1, 2, 3, 4, 5, 6, 7, 2, 2, 3, 2, 1. Okay, again putting the answer. This answer. Three 3.3, 2, 2, 3, 1, 2, 4, 3, 4, 5, 6, 7, 3, 1, 9. Yes. Again for answer, let me check for the answer. Just the 3.322319, right? And then checking for answer again. Just 3.22319049 and so on. Right, let me use the previous one. 3.325982, 3.322321, 3.322319. Okay, now we have to find the answer up to 5 significant figures. The root should be up to 5 significant figure. So we can say the root is, as you can see, we have 3.322319. So 1 2 3 4 5 significant figure. The answer is 3.3223. Yes. Question number 6, part A. Use the trapezium rule with 3 intervals, means n values 3, to find an approximation to this integral. Give your answer correct to 5 significant figures. Okay, so let me apply the trapezium rule over here, which is a equals to 1 by 2 into b minus a over n into the function value at 1 plus 2 times the function value at 2 plus 2 times the function value at 3 plus the function value at 4. Okay, so a is 1 and b is 4. So if I can say 1 by 2, upper limit is b and the lower limit is a, right? 4 minus 1, and n value we have given, which is 3, into f of 1, 6 over 1 plus 1, because square root of 1 is 1, plus 2 times 6 over 1 plus square root of 2, plus 2 times 6 over 1 plus square root of 3, plus 6 over 1 plus square root of 4. Square root of 4 is 2. Yes. Okay, so 4 minus 1 makes 3, and 3 over 3 is just 1. So we are left with 1 by 2 into 6 by 2, plus 2 times 6 is 12 over 1 plus square root of 2, plus 12 over 1 plus square root of 3, plus 6 over 1 plus 2 makes 3. Right, this is 1 by 2. This is 2 times 3 is 6, plus 12 over 1 plus square root of 2, plus 12 over 1 plus square root of 3, plus 2. Right. Okay, so this would be 3 plus 2 makes 5, and 5 by 2, 5 divided by 2, plus 2 times 6 is 12. So we have 6 over 1 plus square root of 2, plus 6 over 1 plus square root of 3. Right. Now we can say that what is 5 by 2 is 2.5. Right. 6 divides 1 plus square root of 2, which is minus 6 plus 6 square root of 2, and 6 divide 1 plus square root of 3 is minus 3 plus 3 square root of 3. Right. Okay, so we can simplify. Now we have 2.5 minus 6 minus 3, which is negative 6.5, and 6 square root of 2. Okay, 6 square root of 2, add 3 square root of 3, which is 13.6814. Right, and subtract 6.5. This is up to 5 significant figures, 7.1814, up to 5 significant figures. This is the answer, approximation for the root. Now for part B, find the exact value of this integral, right? So we can integrate this first. So 2 is outside. Integration of e power x over 2 minus 2 and times 1 over the derivative of x by 2 is 1 by 2. Upper and the lower limit is 1 to 4, right? So this is 2 and 1 over 1 by 2 is 2 times by 2 times e power x by 2 minus 2 from 1 to 4. So we have 4 e power x by 2 minus 2 from 1 to 4. So 4 e power 4 by 2 minus 2 minus 4 e power 1 by 2 minus 2. Simplification, 4 by 2 minus 2. 4 by 2 minus 2 e power 0 is just 1. 4 e power 0 minus 4 e power 1 by 2 minus 2 minus 3 by 2. Then we have 4 minus e power minus 3 by 2 because e power 0 is just 1. So e power answer times minus 4 and add 4, which is 3.1. This is 3.1075, or you can keep the answer as it is. 4 minus 4 into e power minus 3 by 2 is also correct. Now for part C, the diagram shows the curves y. Now for part C, the diagram shows the curves, this curve and this curve, which meet at the point with the x coordinate 4. The shaded region is bounded by the two curve and the line x equals to 1. Use your answers to part A and B to find an approximation to the area of the shaded region. Give your answer correct to 3 significant figures, right? So area of the shaded region is bounded between the two curves. So we have to find the area of the upper curve, the integration of upper curve between 1 to 4, and we got the answer for the first one. So area is basically the integration from 1 to 4 of the upper curve, this curve, which is 6 over 1 plus square root of x dx minus integration of lower curve, which is 2 e power x by 2 minus 2 dx, right? Okay, the first one we have 7.1814 and the second one we have 3.1075, right? Now let me calculate this up to 3 significant figures. We have 7.1814 minus 3.1075. This is 4.0739 or 4.07 up to 3 significant figures, right? Now moving to part D, state with a reason whether your answer to part C is an overestimate or underestimate of the exact area of the shaded region. Now for part D, state with a reason whether your answer to part C is an overestimate. Now for part D, state with a reason whether your answer to part C is an overestimate or underestimate of the exact area of the shaded region. So this is overestimated. Why this is overestimated? So if we can see the shaded region, we have this curve we have given in question 1. We calculated the area of the trapezium between the 2 points, between 1 and 4. And we have considered this additional portion, the upper of this trapezium at 1 and 4. So this is the answer of the shaded region is overestimated, right? Overestimated because we consider the additional portion of top of the trapezium. right? Question number 7, the polynomial p of x is defined by, we have p of x where a is a constant. It is given that x minus 3 is a factor of p of x. Part A, find the value of a. So x minus 3 is a factor, so it means p of 3 should be equals to 0. So a times 3 cube minus 11 times 3 square minus 19 times 3 minus a, this should be equals to 0, right? So 3 cube is 27, 27 times a, 3 square is 9, and 9 times 11 is 99, minus 99, and 19 times 3 is minus 57, minus a is equals to 0. From 27, take away 1 is 26a, and negative 99 minus 99 minus 57, which is 156. If we shift on the other side, it's plus 156, and divide 26 makes positive of 6. So a value is 6, right? Now for part B, when a has this value, factorize p of x completely. So when a equals to 6, what is p of x? Which is 6x cube minus 11x square minus 19x minus 6, right? So x minus 3 is a factor, so if I can use the synthetic division method over here, and we have given one factor. Let me write down the coefficient of x cube is 6, x squared is negative 11, x is negative 19, and constant is minus 6. So 3, bring the 6 down, 3 times 6 is 18, and 18 minus 11 is 7, 3 times 7 is 21, 21 minus 19, this is 2, and 3 times 2 is 6, which is 0 when we add them up. So we can write down p of x as x minus 3 into 6x square plus 7x plus 2, right? Now let me factorize this. 6 times 2 is 12. We need to find the factors of 12, which is 1 times 12, right? 3 times 4 is 12, and 3 plus 4 makes 7, yes. So x minus 3 into 6x square plus 3x plus 4x plus 2. X minus 3 into, taking 3x common, we have 2x plus 1, taking minus plus 2 common, 2x plus 1, right? So the factors are x minus 3, 2x plus 1, and 3x plus 2. So these are the three factors when we factorize this completely. Now for part C, hence find the exact values of y that satisfies the equation p of e power y plus e power minus y equals to 0. So we have given p of x equals to 0. So p of x is x minus 3, 2x plus 1, and 3x plus 2. This is equals to 0, right? So from here we can say x equals to 3, x equals to minus 1 by 2, or x equals to minus 2 by 3, right? Now we have to replace x with, let x is equals to e power y plus e power minus y, right? And we have to solve for y's. So from here we can say for the first one, e power y plus e power minus y, this is equals to 3, the first equation. Let me simplify this. So this is e power y plus 1 over e power y. This is equals to 3. So multiplying by e power y on both sides. So e power y square plus 1 minus 3 e power y equals to 0, or e power y square minus 3 e power y plus 1 equals to 0. E power 2y, not y square, sorry. Right, now we have to use a quadratic formula over here. So we can say e power y is negative of b plus minus square root b square minus 4 times the a value and the c value. divides 2 times of a. All right. So from here e power y is 3 plus minus square root 3 square is 9 and 9 minus 4 is 5, square root of 5 by 2. Right. So what is the y value? So y is equals to ln of this answer, which is 3 plus minus square root of 5 divided by 2. Now next, let me replace this x with e power y plus e power minus y is negative 1 by 2. So again we have to multiply by e power y. So we have e power 2y plus 1 equals to minus 1 over 2 e power y. Right? And we have e power 2y plus 1 by 2 e power y plus 1 equals to 0, or we can say 2 e power 2y plus e power y plus 2 equals to 0. Right, now let me apply the quadratic formula over here. We have e power y equals to negative of b plus minus square root b square minus 4ac. So minus 4 times a times c, which is negative 16, divides 2a. 2 times 2 is 4. So this is minus 1 plus minus square root of negative of 15 divided by 4. So this is a complex root. So we are not dealing the complex numbers, right? Because square root contain negative 1, which is iota, right? Let me check for the third root as well. Can say e power y plus e power minus y is minus 2 by 3, right? Then multiplying by e power 2y plus 1 equals to minus 2 by 3 e power y, right? And we have e power 2y plus 2 by 3 e power y plus 1 equals to 0. Multiplying by 3 e power 2y plus 2 e power y plus 3 equals to 0, right? Now applying the quadratic formula and solving for y. So e power y is equals to minus b plus minus square root b square, which is 4 minus 4ac. So minus 4 times 3 times 3, which is minus 36. Dividing by 2 times of a, 2 times 3 is 6. Now e power y is minus 2 plus minus square root. From 36 take away 4 is minus 32 divided by 6. Again square root contain a negative sign, which is a complex root, right? So the only root is y equals to ln of 3 plus minus square root of 5 by 2. So that is only solution. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.